The Kimball Method slowly changing dimension component. How do I use this thing? In order to create our own flexible slowly changing dimension processing through existing components, we're going to have to use a couple of them. The first one is going to be a lookup. This lookup's job is to find rows in our existing dimension table that match the business keys coming in from our source system. We're going to make it do that through an uncached lookup so that it operates the same as a slowly changing dimension wizard. Then we're going to tell it what to do with rows that it can't find in the dimension. In this case, in 2008, we're going to send them out the no match output. If you're using 2005, you're going to have to send them out the error output. Next, we're going to tell it where to look up the rows. We could select the table, but that'd be wrong because you'll get non-current records as well. So we have to use a SQL query and only look for the current records. And the way we're going to find that out is by looking where the date expires is null. Next, we're going to have to tell which columns to use to look up values. So we're going to pull across and map the manufacturer, model, and serial number because that's our business key. Next, we're going to tell it that we want back certain columns from the dimension table if we find a match. All of our attributes and the surrogate key. I'm going to rename the columns that we get back with dim so that we can identify them separately from the columns that came in from our source system. Next, we're going to handle new computers that come through from the source system. So we need a derived column component and an OLADB destination to do that. Now we're going to handle those rows that come out the no match, which will be brand new records, by pulling off the no match output, putting it through a derived column where we're going to add an effective date of the day that we're doing the processing, and then put them into an OLADB destination where we're going to add them to the database. Inside the destination component, we pick our connection manager, pick the table that we're inserting into, and all the mappings are correct. The next part is that we're going to have to figure out what's changed in those rows that did find a match through the lookup. We're going to do that by using a derived column component and a conditional split. Now you can do all the checking just within one conditional split, but I like to split it out, and here's why. You don't get a lot of space editing expressions in either the derived column component or the conditional split, so I find it very useful to break them up and do things one step at a time. So I'm going to make one column for each attribute that I'm checking to see what change was made. Doing this allows me to isolate those changes into a smaller expression, as well as handle any kind of custom expressions to do things like trimming off spaces or checking things on all in uppercase in one simple expression rather than one big expression. Splitting things up into two steps gives me simple columns that just identify whether or not that attribute's changed as a Boolean value. Now deciding what to do with each row is easy. The first thing you need to test is for type 2 changes. So we're going to do that as the first condition in the conditional split. We're going to build the condition with those easy to use Boolean values that we created in the conditional split. Then we'll use a second condition to find those rows that have only had changes to them that we want to update in the dimension but not make a separate row for. Do keep in mind that our first condition will also catch those rows that have both changes to them, SCD1 and 2's, and we're going to have to handle that later. Anything that doesn't have any of those conditions has no changes. So now that we've detected those changes and classified them, we're going to handle the type 1 changes by using an OLADB command, hook that up to the changed information. Need to select the connection manager, and then we're going to set the SQL statement that we're going to use to perform the update. And here we're going to set all those type 1 columns by referring to the business key and updating all previous versions as well. The next tricky part is configuring the OLADB command, because it is difficult to find out which columns should go to which parameters. but you can float over them and get the metadata just to double check. It does show them, those parameters, in the order that the question marks appear in the statement, so you can use that as a guide as well. The other output of our conditional split is pushing out the new versions, the type 2 changes. But the first thing we have to do is to make sure that we update the expired version of those rows with any type 1 changes that happen, because those will come out of the new row version output as well as the changed information, because there may be mixed type 1 and type 2 changes to the rows that come out of here. Let's configure this OLADB command the same as the one we did for the other output of the conditional split, because it's going to do exactly the same job. Now obviously, when you make your package, you can make a bunch of improvements and consolidate things and optimize things so that you're not doing so many different transforms, but I wanted to break it down to make it a little easier to follow what's going on. Now it's time to mark the old version of those rows as expired. So we're going to add a derived column component to put an expiry date into the flow. And we're going to set that expiry date to the date that we've set in our variable minus 1 day, so it expires yesterday. We need to place another OLADB command component on the surface to send those updates to the dimension table. We're going to do this update by the surrogate key, which we retrieved from the dimension. And so again, be careful how you hook these up, pay attention to the data types. Now we have to add the new records in, since we've expired the old ones. So first thing we need to do is add a derived column that's going to add a new effective date to the flow, so we can use that to insert with. And we'll use an OLADB destination to put those new rows into the dimension table. First thing we have to do is make an effective date based on our loading date. Then we'll set up the destination to insert the new records. We select our dimension table from the drop-down and examine the mappings. They're all good. We don't want to use those dimension ones. Those are the old values. And we're going to map our new effective date to the effective date in the dimension table. Now we can execute the data flow and see if we get the same results as we did with the wizard. You'll see we got 3 rows in again from our source system. Our lookup didn't find any missing keys, so everything went through the lookup match output where we detected changes. We had 1 row with type 1 changes and 1 row with type 2 changes, and don't forget we had to update the type 1 type changes in our type 2 records just to make sure in case there were any. Next, we had to expire the old row and then put a new date in for the new effective date of the new row, and then we saved the new row into the database using the OLADB destination. Now we can run the cleanup to take a look and see if we got the same results as the wizard did. You can see we got the 5 expected rows in our dimension table with correct dates in them on the effective and expiry. Our new row has the Ultimate, Windows 7 Ultimate on it, and we fixed up the John Doe. If you're still awake, we'll put you to sleep in the next video using the T-SQL MERGE command to do the same thing.